Hello everyone. In this lesson, we are going to be talking about polyatomic ions. By the end of the lesson, you should be able to name compounds that include polyatomic ions and write the formula of compounds that include polyatomic ions. So once again, let's break down what this word means. Poly meaning multiple, and atomic meaning atoms. And well, ions are charged particles. So in this lesson, we are talking about ions with multiple atoms. Previously, we had discussed atoms or ions with only one atom or only one element, I should say. So for example, Na plus, that's an ion, but there's only one element involved. Cl minus, that's an ion, but there's only one element involved. So if we scroll on up to check out our handy dandy periodic table of ions, you will see this table up here. This table up here shows us our table of polyatomic ions. And what you will notice if we zoom in is that there are multiple different elements involved in each ion. So if we take a look at this hydroxide ion right here, you can see that it is made up of an oxygen, a hydrogen, and it has a charge of -1. Or if we take a look at this nitrate ion right here, it is composed of a nitrogen, an oxygen, well actually several oxygens, and has a charge of -1 as well. Most of these polyatomic ions are going to be negative, with the exception of ammonium and hydronium. So let's start with naming compounds with polyatomic ions. The first thing you need to do is take a look at the formula that you're starting with. Right off the bat, you should notice that there are 1, 2, 3 different elements. And that tells you that you are probably working with a polyatomic ion. So I know that this is sodium, so I am going to rewrite the metal. This is just like naming of ionic compounds. So rewrite the metal first, and then I'm going to rewrite the second part. When working with nonmetals, I would write chloride or sulfide, or I would just write the nonmetal with the IDE. But in this case, we are working with polyatomic ions, and they have special names. We need to rely on our table of polyatomic ions up here. So we're relying on our table of polyatomic ions. So what I am going to do is I'm going to search my table for the basically what matches my formula. Now I'm looking for OH. Sometimes it might be written as HO, but I know that it is right here, so OH. Now this OH has a special name and we call it hydroxide. And so all I have to do is write down that special name, hydroxide. It is as easy as that, writing down the name of the metal, then writing down the name of the polyatomic ion, in this case, hydroxide. Okay, here's another one for us to practice on. So this is KCN. Again, right away I am noticing 1, 2, 3 different elements, potassium, carbon, and nitrogen. That tells me that I need to be relying on my polyatomic ion table here, which is handily right above. So K, if you go and check the periodic table, is going to be potassium. So the metal will always be the first one, potassium, and I'm sorry, I think I misspelled that. And then you are going to be looking for this second part, Cn, in our table of polyatomic ions. Now I know that Cn can be found right here. And in order to write the name of that Cn, all I'm going to do is copy the name that is in the table. So in this case, Cn The name for CN is cyanide. So we have potassium cyanide. Okay, I have put an example right here for you that I would like you to try out on your own. So pause the video, give it a try, and try and figure it out. Now I'm going to go ahead and solve it for you to be able to check your answer against. So once again, I notice we have 1, 2, 3 different elements involved in this formula, which tells me I need to be relying on my table of polyatomic ions. So K is still potassium from earlier. Let's try with 2 S's. Does that look right? Not sure. And then I am going to be looking for my polyatomic ion in my table. Now I know that this can be found over here. Pay particular attention to this 4. Because over here, you will see there is 1 with a subscript of 4, that's sulfate, and 1 with a subscript of 3, that's sulfite. They are different ions, so pay careful attention to that because that is a common mistake that I see. In this case, we have a 4, so I know that I am working with sulfate. And so I'm going to write that down, potassium sulfate. Next up, we have to talk about writing the formula when starting with the name. Okay, so here's an example. We have lithium hydroxide. Now, when reading this, lithium is fairly easy to identify as the metal. However, if you are unfamiliar with the polyatomic ions, you're going to be looking at that second word to identify, are we working with polyatomic ions? Are we working with multivalent metals? Are we working with just your sort of common average metal? When you see this, you should be able to break down the word. Hydra, so like hydrogen, oxygen, oxide. So that is telling you that there are, once again, 2 elements involved, and you should recognize that it's kind of a funny word, so you know what, just double check the table of polyatomic ions. Some of them are going to be totally random, like cyanide. You will not find that on the periodic table. If you're having a really hard time finding things on our periodic table, then check the table of polyatomic ions. Eventually, you will get more familiar with which ions are polyatomic and which ones are on the periodic table. So it just comes with practice. Again, we are going to be starting out by writing the symbols. So lithium, that's pretty easy, that's Li. I have recognized that hydroxide is a polyatomic ion, so I'm going to find that up here. And so that's OH and has a charge of -1. So lithium OH. Now that we have the symbols down, we are going to have to write the charges or figure out the charges. So lithium is in that first column of the periodic table, making it a +1. And hydroxide, if I check my table up here, is -1. So that's going to have a -1. So 1 and 1 cancel out, leaving lithium hydroxide to be our final answer. So this right here. Okay, so this is another practice problem for you. If you feel ready to try it on, go for it. If not, keep watching. So we have magnesium carbonate. Once again, we are recognizing that this is kind of a strange word. It involves carbon, but it doesn't have an "ide" like you might expect. So anything with an 8 or an "ite" may fall under the polyatomic ions. So once again, writing out the symbols for my different ions. So magnesium is just going to be Mg, and carbonate I'm going to find on the table of polyatomic ions, and it's going to be over here with the rest of the C's. Let's see, there it is, CO3, and it's going to be a 2-. So I'm going to write CO3, and its charge is going to be 2-. Now, magnesium is going to be a 2+. And once again, these cancel out, leaving us with a final formula of magnesium carbonate. Now let's explore an example where they don't cancel out. Let's say instead of magnesium carbonate, we had magnesium hydroxide. So hydroxide. Now we recognize that from earlier, magnesium hydroxide is, or hydroxide is going to be that OH ion. OH ion. But once again, hydroxide is -1 and magnesium is going to be +2. So when we do the swapsies of our little charges, this will have to be magnesium hydroxide, and we're going to have to add a 2. Now here's the thing. When we put a 2 behind this hydrogen, it is telling the reader that there's going to be 2 hydrogen. But that's not what we want. We want there to be 2 hydrogen and 2 oxygen. Now, hypothetically, we could put a 2 here, but that's not what's done. Instead, what we will do is kind of pretend like it's math and put parentheses around the hydroxide ion. Now, just like math, this tells us that there are 2 hydroxide ions and 1 magnesium ion. Okay, here's one last sample problem for you to try on your own. Please pause the video and give it a try, and then check your answers off of mine. And I'm going to go ahead and solve this now. So sodium is going to be Na, just basing that off the periodic table, with a charge of +1. And phosphate, that's a funny word, so I'm going to know right away that I need to check my table of polyatomic ions, and that's going to be found right here. So that's PO4 with a charge of 3-. Then we're going to do a little swapsies with my charges in order to balance out that. So we will have 3 sodium ions and 1 phosphate ion. And that's our final answer. So that is our lesson on polyatomic ions. You should be able to name them as well as write their formulas. As always, do practice this. It's just like math in that in order to get good at it, you will need to practice. And as always, good luck.